10, 11, 12 want you to write a complex number like -1 plus 2i. Complex numbers have imaginary numbers. And they want you to change it into trigonometric form or what's known as polar form. So remember on that previous one when we had that polar form, we had the direction and then we had the angle. So it tells us here that in order to do that, z is going to equal r times the cosine of theta plus I sine of theta. Now r is my radius, and so if I'm thinking about this again with my right angle, -1 would be back 1, 2i, we're just going to ignore the I part of it and make it a 2, and so my radius is still, again using my Pythagorean theorem, is the same thing as when I'm finding the magnitude. I'm just finding the length of this direction right here. So I'm going to do a squared plus b squared and take the square root of that. So in this case, I'm going to have the square root of -1 squared plus 2 squared. So 1 plus 4 gives me the square root of 5. Now again on this one, we want to have our values rounded off to 2 decimal places, which tells me I don't want to leave it in radical form. I want to change it to a decimal. So I'm going to calculate there what the square root of 5 is. Square root of 5 is 2.236, so rounding off to 2 decimal places, 2.24. So z is going to equal 2.24, and now I got to find the other part of that. Now, if I think about this, the angle is what I'm looking for. So again, I have the opposite and the adjacent, so I'm going to do the inverse tangent of the opposite over the adjacent. Now this is going to be in radians, and so you need to switch your calculator from degree mode to radian mode. So mode 2, so that I have a little r on the top, tells me I'm in radian mode. I'm going to do the inverse tangent of the opposite over the adjacent, so 2 over -1, so the inverse tangent of -2. So shift tangent of -2 gives me -1.1071. Now, they're going to want these angles in the positive direction instead of the negative direction. And so in this case, this is the -1.1. I actually want to find the angle here. And so this way from here to here is pi, right? It's half a circle. So pi, 3.14159, and or use the button on your calculator. So I'm going to take pi minus my 1.1071. Again, they don't want you to round off too soon. Don't round your intermediate computation. And so I'm trying to find the angle from here to here. On my calculator, I have a pi button. It's in yellow. So I'm going to hit shift, pi, and then I'm going to subtract my 1.1071. And so now I get 2.0344. I'm going to round that off to the nearest hundredth, so 2.03 is what I'm going to use there for my angle. So I'm going to have cosine of 2.03 plus I sine of 2.03. And that's how my angle is going to look as a polar form or trigonometric form instead of in complex number form or imaginary number form. So my radius, finding the magnitude of this line here, just like I did before, the square root of a squared plus b squared. Then I'm going to find this angle. If this angle is negative, I've got to convert it to the positive direction. So in this case, to figure that out, I would have had to take pi minus my angle, and then I can find what this measurement is here. So number 11, we want to write the complex number z equals 2 plus 6i in trigonometric form. So thinking of that, this being 2 here, this being the 6 here, and my angle is going to be there in quadrant 1. So, first of all, calculating r, square root of 2 squared plus 6 squared would give me 4 plus 36, so square root of 40. I'm going to use my calculator. Square root of 40 gives me 6.3245, rounding to 2 decimal places, 6.32. So, z is going to equal 6.32, and then I'm going to do the rest of my problem there. For the rest of my problem, I'm going to use the inverse tangent. So inverse tangent of the opposite over the adjacent, so 6 over 2. So inverse tangent of 3. My calculator's in radian mode. Shift tangent of 3 gives me 1.249. So rounding that off, I would use 1.25. That is a positive, and notice I'm in quadrant 1, so that is my angle that I want to do. So I'm going to have the cosine of 1.25 plus I sine of 1.25. And so z is equal to 6.32 cosine of 1.25 plus I sine of 1.25. Number 12, same kind of thing. Thinking about this in terms of my right angle, I'm at 6, -5, so I'm going to be down here. So, finding my r. R is going to be the square root of 6 squared plus -5 squared. 36 plus 25 gives me the square root of 61. So I'm going to calculate the square root of 61 with my calculator. I get 7.8102, rounding to 2 decimal places, 7.81. So z is going to equal 7.81 times, and then I'm going to do the rest of my problem here. So I'm going to do the inverse tangent, and my opposite would be -5 over my adjacent 6. I should have probably wrote that up there. It would have looked better up there. So, opposite over adjacent, -5 6. Because it's a fraction, I'm going to use parentheses around that. Inverse tangent of parentheses, -5 6 gives me -0.6947. Again, that's a negative measurement, so I'm going backwards from here to here. I really want the angle going around from here to here. So in this case, 2 pi would be all the way around. I'm going to take 2 pi minus my 0.6947. So on my calculator, I'm going to do 2, shift, and get the pi button. You could use 3.14159 if you need to round off pi if you don't have a pi button. But 2 pi minus my 0.6947 gives me 5.5884. So 5.59 is what my angle would be in the positive direction. And so I'm going to have the cosine of 5.59 plus I sine of 5.59. Smoosh that all in there. And that's going to be my answer in polar form. So always look if you do get a negative angle where you're at, because you want your angle in the positive direction. If it's up here in quadrant 2, you're going to take pi minus the angle. If you're in quadrant 3, you would take pi plus your angle. If you're in quadrant 4, 2 pi minus your angle.